We're on topic 16. We're going to try and show that Desmos can be used a number of problems in topic 16. We go to page 84. Here is the example that's given and that was solved. And so if we enter that equation into Desmos, we get a non-acceptable entry. This little triangle here means that with the exclamation part means that Desmos won't solve it. So what I've done is multiply both sides of this equation by 5x, which means essentially multiplying each term by 5x. If I multiply this by 5x, I get x plus 6, because the 5x will cancel the top and bottom. I multiply this by 5x, I'll get 10x over x, which I can reduce to 10. And if I multiply this by 5x, I get 5x over 5, and the 5 cancels, and I'm left with minus x. And lo and behold, Desmos is able to solve this and say that the solution to this equation, which is the same as the solution to that equation, is x equal to 2. Now there's another way of doing this problem, and what we can do is we can take this part here and graph it, y equals x plus 6 over 5x, and this is black, so the black line here will be this line here and that line here. Now I know this graph is not one that we're used to and we'll probably have not discussed. It would probably be the discussion of a later course, but it isn't really that important. What we have to look for is we have to look at point of intersection. There are two graphs here. The other graph is this one here. So one side is the left side of the equation, y equals this. Another graph is the right side of the equation, and what we're really looking for is an x value that's common here and here, and that happens to be right over here. In other words, the two lines cross. Say, well, what about over here? I can't really see what's going on. Well, that's because I've cut it off. There isn't any other point of intersection. This is the only point of intersection when x equals 2, which is the same as we got here. So let me reiterate. You plot the left side of the equation, you plot the right side of the equation. They give you two independent graphs, but what you're looking for is an x value that lies on both graphs, because if it lies on both graphs, it is the solution. If what you're looking for here is an x, and obviously they must be the same. So we have two ways. Can either calculate it or graphically, and that's going to be a big theme in this part of the course and to show the usefulness of Desmos. Now again, here I've got an equation, page 86 1b. Here it is. Put it in to Desmos. It has no problems because it's a relatively simple equation, so Desmos doesn't really have any problems with this. It calculates it as x minus 22, and that should be enough. But what I also do is plot the left side of this equation. And by the way, I don't have to write y equal to. I can just put this in, and it plots it as a straight line. Okay, and you know that it plots it because there's a little line here that indicates there's a graph. And then I plot the right side of the equation, which is this. So we have two independent straight lines. Both of these are straight lines. And the point of intersection is at minus 22, which is right here. So whether we do it graphically or we do it algebraically, we get the same solution. Page 87, number 3L. Put this equation in, and you can see I get the little triangle. It doesn't like it. So what I'm going to try and do is multiply each term by the common denominator, x squared minus 4. I'm going to multiply this by x squared minus 4. I'm going to multiply this whole term by x squared minus 4. And I'm going to multiply this by x squared minus 4. When I do that, 1 times x squared minus 4 gives me that. Here, when I multiply by x squared minus 4, the term cancels in the top and the bottom, and I'm just going to be left with 12. And here I'm going to multiply by x plus 2, x minus 2, because that's the same as x minus 4, x squared minus 4. The x plus 2's will cancel in the top and bottom. I'll be left with 3 times x minus 2. Lo and behold, I get 2 solutions. Now, you have to be very, very careful here, because if you put minus 2 back into the original equations, let's say right here, it becomes 3 over 0, and 3 over 0 is undefined, so you cannot have the denominator be equal to 0. So this is not a valid solution. You put minus 2 here, you're going to get 4 minus 4, you're going to get the same thing. So the only real valid solution is the 5. So you almost must go back and check. Now what I've done here is to plot the left side of the equation and then plot the right side of the equation and look for a point of intersection. And you can see the only point of intersection is where x equals 5, which agrees with this. So I think this is a very neat way of showing it. X minus 2 is not a valid solution since the denominator of the two terms in the equation will be undefined. Actually, the fractions will be undefined, not the denominator, but the denominator will be 0, which makes the fraction undefined. Okay, next problem right over here. We go over here. We have this equation 87, number 3x problem. I put it in here. Desmos doesn't like it. And so what I've done here is factor this term, and this term, and I get that. That's essentially, well, why have you done that? Okay, you're going to see when I go to the next step. So there's no difference really between box 1 and box 2, except I factored it. It still doesn't like it. But what I'm going to do is multiply through by the common denominator, which is x minus 2, x minus 1, and x minus 3. So that's the common denominator. I'm going to multiply each term by that. The first term will give me x plus 4 times x minus 3, because the x minus 2 and the x minus 1 will cancel in the top and the bottom. Go back to my original discussion and video of non-Desmos discussion, and you'll see how I did that. Second term, again, I'm going to multiply through by these 3 terms. The x minus 3 and the x minus 1 cancel, so I'm left with 5 times x minus 2. And here, when I multiply by this, the x minus 3 and the x minus 2 cancel, and I'm going to multiply this term by x minus 1. And lo and behold, Desmos now likes this, and it gives an example of 6. To go from here to here to here, I'm just simplifying. So I'm removing the brackets, get these 3 terms here, minus 5x right here, minus 5 times minus 2 is plus 10. Here I'm using the I'm expanding this and then taking care of the sign. I'm left with minus 5x minus x squared plus 5x minus 4. Now notice the x squared and the minus x squared canceled, so there's no x squared term. The plus x and the minus 5x and the plus 5x become just x. So actually the minus 5x and the plus 5x cancel. I'm just left with x. And then minus 10, minus 12 plus 10 is minus 2, and minus 4 gives me minus 6. So x equals 6. Now you don't really probably need to do all this. It's just interesting to show that the answer doesn't vary. So I get an answer of 6. And now if I plot this, the graph looks like this and like this. As I say, don't worry too much about what's happening here. That's more complicated. What we are looking for is, because y is set to 0, we set y to 0, it's along this line, and you can see x is 6 when y is 0. X is 6 when y is 0, in agreement with the calculated solution over here. Page 87. And now this is number 3z. I left out the number 3. I put this equation in here. I get this, and I get the two solutions, x equals 2 or x equals minus 6. So the other way, I do the graph. Don't worry about the shape of this graph. We'll be discussing it later on. It's a parabola shape, which is, in this case, it's like a U-shaped kind of a graph. So I haven't shown the bottom part of the U here. But what we do look for is the values when y equals 0. So when y equals 0, right here, the values are minus 6, x equals minus 6, and plus 2. We get exactly the same values whether I do it by calculation or graphically. One number must be subtracted from each term of 9/17. So here we have 9/17. We subtract the x from the top and the x from the bottom, and it gives us yields 1/3. So if I put that in here and solving for x, it doesn't work. But if I cross multiply and say 3 times 9 minus x equals 1 times 17 minus x, I get that, and x equals 5. It gives me the solutions. And no graph or anything, but if I plot the left side, do a graph for the left side, and plot for the right side, here is y equal 1/3 right over here, because this is 0 and this is 0.5, so 1/3 is 0.333. It's right here. Of course, the y must equal that. And this line intersects this line and this line here that's going down like that is this one right over here. Intersects with y equals 1/3 at a value of x equal to 5. So we get the solution by calculation. Here we get it graphically. A man spent a quarter of his life in school after 4 years of early childhood. Also, he spent 3/7 of his life working and enjoyed 23 years of retirement before he died. How old was he when he died? So we're going to let x equal his age. We've done this problem and we just let x equal his age. We subtract out the 4 years of early childhood. We subtract out the schooling, x over 4, and we subtract out the years that he was working. And when we do that, we're left with the years that were left, which are the years of his retirement, 23. So his age, subtract out his early childhood, subtract out his schooling, subtract out his working years, and you're left with the years that he was retired. X calculates this as 84. So you have 84 minus 4 minus 84 over 4 is 21. 3 times 84 over 12 is 36. So you've got 84 minus 4 minus 21 minus 36. And if you check that and do that, you'll find that it's equal to 23, which it should be. So this completes our discussion of topic 16 and how we can use it and apply it, how we can use Desmos to help us solve problems.